Okay, so find the volume of the solid whose base is bounded by this circle, and the cross sections perpendicular to the x-axis are equilateral triangles. So first, draw a picture. Okay, so the radius of this, the center is 0, 0, the radius is 3. Okay, so that's the region. And the cross sections perpendicular to the x-axis are equilateral triangles. So let me draw some cross sections. Okay, so like here would be one, there'd be another, just like till you get the idea. Okay, and there's infinitely many of them. And then, okay, so we're definitely using a volume formula. So which formula? So we've got vertical slices, so we're using formula 2. Okay, so which formula? Number 2. So it's going to be the integral from, okay, so x values, so that'd be -3 to 3, so volume equals. All right, and then inside here, we need to know the area formula for equilateral triangles, and it's square root of 3 over 4 base squared. Okay, and now the way that we find the base is going to be by doing top minus bottom. Okay, and it's not necessary to like write all of this. I mean, let's write it for our notes, but when you're doing the problem yourself. So radical 3 over 4 blank squared dx. Okay, so since it's in terms of x, the way that we're going to find the base, so this is the base of the equilateral triangle, is by doing top minus bottom. Okay, so now we've got to find the top function and the bottom function. I haven't done that yet. So this x squared plus y squared equals 9. So we want things in terms of x, meaning that you solve for y. So this is y equals, you're going to end up with plus or minus radical 9 minus x squared. So in terms of x means you solve for y. In terms of y means you solve for x. So now I go over here. So the top half of the circle is the positive square root, and then the bottom half is the negative one. All right, so when you do all right, so let me just do this. So the volume is equal to this radical 3 over 4, all right, base squared dx. So when you do top minus bottom, I'm kind of going to skip a step here. It's going to be radical 9 minus x squared minus negative radical 9 minus x squared. So you're subtracting a negative, so you're really adding these. And they are the same thing, so you can just combine them. So you're going to have 2 radical 9 minus x squared, because this minus this is this plus this, so it's 2 of these. Okay, and then you would do, what did I write in my notes? Okay, then you would do FTC or Math 9, depending on if it was a calculator section or not, and I'll spare you the having to watch me plug it into the calculator. It ends up being that. Okay, so let R be the region bounded by y equals radical x. Okay, so that looks like this. The line x equals 16. and the line y equals 0. So that is the x-axis. So if you want to see the region, just put dots on their intersection points, and then those are like the vertices of the shape. So that's the region. Find the volume of the solid obtained by revolving R around the y-axis. So we're revolving around the y-axis and draw one cross-section. Okay, so since there's this empty space between the center of the rotation and where the region starts, it's going to be a washer because you're going to have that empty space, and then when the region itself is rotating, that's going to be filled in. Okay, and then like imagine this region like reflected over here, you know, and it's going like that. So you're going to have like kind of like a weird bowl. Okay, it's going to look like the bowl, I guess it's kind of going to look like a cylinder. It'll kind of look like a cylinder, but then you're going to have like this empty space in there looking sort of like a weird curved cone, but that'll be like the empty space inside. Okay, so volume. Which formula? So these slices, which are washers, are horizontal slices, so we're using this volume formula here. So it is number 4. So things need to be in terms of y. We need the area in terms of y. So we've got to solve for x here. So this is x, so or x equals y squared. Okay, so another way of expressing this is this. So this curve here in terms of y is x equals y squared. So the volume is equal to the integral from, okay, the lowest y is 0. The highest y value is up here. And this is, its x coordinate is 16. And to get the y coordinate, you can plug 16 in here, and you get the square root of 16, which is 4. Okay, so the highest y value is 4. And then you plug in the area in terms of y, but first I'll just write the general area formula. So it's pi big R squared minus little r squared. That's the area of a washer. Volume equals 0 to 4 pi. Okay, now big R, okay, big R is this, and we're going to get it by doing right minus left. Okay, right minus left squared, oops, I need a parentheses there, minus little r squared yeah, is that good? I think my parentheses are good. Okay, so little r squared, this is little r, and you're gonna need right again. This right minus this left. Okay, so I'll call this right 1, and I'll call that right 2, I guess. So right 1, right 2 minus left. Okay. So the volume is equal to the integral from 0 to 4 pi. Okay. This right minus this left is 16 minus 0, so that's just 16 squared minus this right minus this left is y squared. Okay, that's y squared minus 0, which is just y squared squared. Okay, and then you do, FTC or Math 9, depending on the situation, and we end up with 2573.593. Okay. So 2 more of these. Okay, so we're going to do these 2 examples, and then I have to back up, and I'm doing these on a separate sheet. So I think my brother is coming to pick me up soon. I'm still at school. My car's in the shop. So I'll probably have to do a 3rd video, guys. All right, so I think I'll have to do a 3rd video. So anyway, I can finish these. Okay, so this one here. So find the particular solution, y equals f of x, so means solve for y, to the differential equation with this initial condition. Okay, so this is our most recent stuff that we learned. So you've got to separate the variables here. So I'm going to do it fast, and if you don't understand how I did it, you've got to pause and figure out how I got that. Okay, you want to understand absolutely everything I do. All right, so here I have separated the variables. Then you take the antiderivative, so you put in the squigglies. The antiderivative of this is f prime over f, so it's just the natural log of the denominator, equals, this is a 5th, x to the 5th plus c. Okay, now since this is a natural log, I'm going to put a base of e on each side. So these will cancel, and this is just absolute value of that, equals e to the 1/5 x to the 5th times e to the c. So I'm just splitting this up. Okay, now think backwards, guys. If you were to multiply these, since they have the same base, you would add those exponents, so you'd get that. So I'm just doing that backwards. All right, now I can drop the absolute values. I'll change e to the c to k, and then I'll tell my reader that k is plus or minus e to the c. It is the plus, accounting for the plus or minus is what allows me to drop the absolute values. Okay, now I'm going to use the initial condition. So I plug in 0 for y. Okay, so there's the initial condition. So that's x, that's y. So initial condition, 0 goes in up there, so it's e to the 0, so that's 1. Okay, so you end up with y minus 2 is negative 2 e to the 1/5 x to the 5th, and then you add 2 to both sides. Okay, I can squeeze in another. So this one here, again, find the particular solution to this differential equation, and they want it in this form, meaning that we have to solve for y. So this, I'm going to end up with this. Okay. And then I take the antiderivative of both sides. 1/2 y to the 2nd. Oh shoot, I probably should be doing the bracket things, because I feel like that's helpful. But I don't have an eraser. 1/2 x squared plus x plus c. Okay, now let me find c, and then I'll solve for y. So I'm plugging in 0 for x, and negative 2 in for y. So this is 1/2 negative 2 squared. So we get that c is just positive 2. Okay. So I get 1/2 y squared equals 1/2 x squared plus x plus 2. I've got to solve for y. So I'm going to multiply both sides by the reciprocal of this, which is 2 over 1, which is the same thing. Dividing by 1/2 is the same as multiplying by 2 over 1 because of, say, change flip. So this is y squared equals, I'm distributing this to everything, x squared plus 2x plus 4. So y equals plus or minus radical x squared plus 2x plus 4. Now here is the thing. Is it the plus or is it the minus? It can't be both. Because, and the way that you figure out is that you go back to the initial condition. Always go back to the initial condition. So f of 0 equals negative 2, negative. So y has to be, in order for f of 0 to be negative 2, it would have to be the negative version. Okay? Otherwise, f of 0 would give us positive 2, and we want it to give us negative 2, so the negative version. So y equals negative radical x squared plus 2x plus 4. Okay, guys, so there will be one more video where I do this stuff on a separate sheet. Okay, so this will be in the third video. Okay?